In this video, I would like to tell you about mechanics of materials. Especially, I would like to tell you about problem-solving process for mechanics of materials. When you see textbook or when you see reference book, there are so many problems inside books. When you see that books, maybe it's very difficult to solve systematically. Today is the first class for solving problems, especially topic is tension and compression. Today we will think of tension and compression, but main target is to find stress and strain and maybe displacement. In many cases, we need to find stress. Why we try to find stress? Because we would like to know what's the minimum size or what's the adequate size of the component. In order to that, we calculate exactly what's the reasonable size, what's the minimum size for the component of the structure of the machine. Okay, let's see step by step. Today is the first time, and tension and compression, let's think about that. Generally, when you think about this kind of issue, general guideline is like this one. The most important thing is read the problem carefully. It's very important. You must know the problem exactly, what you try to find. That's very important. And when you read problems, then units, for example, in some cases millimeter, in some cases kilometers, is different. When you mix it up, then you can have finally very different answer. Next, draw free body diagram is very important. If we have proper free body diagram, maybe problem solving is very easy. Or someone say problem solving process is to draw, how to draw free body diagram. That's the way of solving problem easily. How you can have intuition about free body diagram. Next, you can apply formula to the free body diagram, and if you get some equations, then you can calculate by hand, or in some cases you can use computer systems or softwares that's available. Finally, you can get solutions. You can have many solutions in some cases, but you must check finally physical meaning. Physically, the solution is acceptable or not. When you consider that, finally you can show the answer. When you follow this process, it's not so difficult. You can solve problems step by step, and finally you can have some intuition. Okay, let's move to first problems. Okay, first problem is like this one. Example 1 is this one. It's a kind of a cylinder. Of course, inside is empty. And upper part is sealed with very robust one. On the bottom here, this one is also, bottom plate is very rigid. Therefore, we assume both of them, top and bottom, is not changed, is straight. Often we introduce many assumptions. In this case, we introduced rigid body. When you introduce rigid body, the problem is more simple. It's much easier to tackle it. In order to that, we introduce many assumptions. For example, rigid body, or in some cases, the homogeneous. When material is homogeneous, inside material itself is very uniform structure. Then we can eliminate many, unexpected factors related to material itself. Or in some cases, we introduce neglect self-weight. Strict calculation, self-weight should be considered. But when you think about self-weight, then the problem is very complicated. In that case, it takes a long time, it's very heavy calculation is required. Therefore, in many cases, self-weight is neglected for simplicity. Actually, there are so many assumptions are introduced for problem formulation. And you must be careful about assumptions, because finally, when you have some solution, and it should be coincide each other with assumption and solutions. If you consider the assumptions, your solutions are based on certain kind of assumption. Okay. Therefore, when you interpret solutions, you must follow the assumptions. Otherwise, you have a very wrong answer. Okay, let's go back to this problem again. When you think about this kind of cylinder, okay, when you cut here, then you can draw cross section is like this one. Okay. Outside diameter, let's say here we do not know, let's say outside diameter, the out. Or inside diameter, okay, this one, inside diameter, let's assume inside diameter, the I. Okay, here we would like to know stress. Stress is sigma. Which is stress? Stress which acts on inside of the cylinder. Stress is actually calculated by external force is divided by A. Okay, external force here is 26 kilo, let's say pound. Okay, and cross-sectional area, A is 5/4. When inside is solid, then just we can apply 5/4 d squared. But here is slightly different, because this structure, so when you consider this structure, then d outside squared minus d inside squared. Okay, of course here inch squared. Okay, then finally you can have some answer, and unit is what? Unit is kilo-pound per inch squared. Kilo-pound per inch squared. Okay, I review this one again. If we have this kind of structure which has cylinder, inside is empty, and the outside and the inside diameter is given like this one. And externally 26K and length is 16 inch, and here diameter is not known. Okay, that's the sigma is like this one. External force is divided by A. Next one, we would like to calculate epsilon. Epsilon is what? Change of length is divided by L. When force is acting like this one, total length is reduced. That's the delta. We don't know at the moment. L is 16 inch. 16 inch. When delta is given, then we can have some value. Important thing is you do not have any dimension for the strain. Okay, stress and strain you can find with this kind of process. Okay, that's the for example 1. Okay, next example 2. Example 2 is like this one. Example 2. Here we can consider this system. Okay, there is a cylinder or diameter is relatively small, d, and length is L, and self on the bottom the weight W is attached, and we would like to calculate this elongation delta, and modulus of elasticity or Young's modulus is given like this one. Young's modulus is given like this one. Okay, in this case we would like to know delta value. And here for the simplicity we neglect self weight for this bar is neglected. Maybe in future and some time self weight can be considered for exact solution. We would like to know delta value. Then maybe we can draw free body diagram like this one. Okay, long okay, this one, and here some forces acting and W, and here so far L, this length is L, and the elongation delta we can expect. Okay, we want to calculate this delta value. Then we can apply sigma equals E epsilon. Actually, this one is Hooke's law. When you draw a sigma epsilon curve, sigma equals epsilon, then this kind of linear relationship. This linear relationship is considered in the range of elastic. In the elastic range, you can consider this one, this amount of 1. Okay, when you extend this one, P over A equals E epsilon is delta over L. And delta is finally what? P over A and L and E. And we know P value, A is calculated by 5 over 4 D squared, and E is what? Modulus of elasticity, or modulus, Young's modulus, we can say. L is given. Then finally, we can calculate in millimeter elongation. We can calculate. Okay. So far we thought about two questions, two problems. During solving problems, it's very important with pen. When you just hear or when you just see with your eyes, then you cannot solve problem properly. Please read carefully, use your pen, and solve problem by yourself. Thank you very much for your listening.